is going to talk to us about packages in PyPI, and unfortunately I think partly because of time eaten into, but I think he's also not going to have time for questions afterwards, but are you around at the conference? So people can come up and ask questions and catch him later. All right, let's give him a warm welcome. Thank you.
Hello everybody, sorry we're a bit late starting. Okay, so this was already a talk that I have to run through really fast. So can everybody hear me, by the way? Yeah? Bit quiet at the back?
The audio is not coming through much.
Okay, can somebody turn me up? I'll just talk really loudly. You can use this one. Thank you. Okay, so I changed my talk title, I couldn't resist the alliteration, so we got publishing perfect Python packages on PyPI. You can judge for yourself whether they're perfect. But first let me introduce myself. This is me. I am GD2K on Twitter. My name is Mark Smith. I'm a developer advocate for Nexmo. Nexmo, I stole this slide from one of my colleagues who's a much better designer than me. Although it's not really coming out on this projector, unfortunately. My employer Nexmo provides web-based APIs that allow web developers to write code that send text messages, make phone calls, and send messages via different instant messaging platforms. If that sounds interesting, come and talk to me at the conference. I can give you free credit, and that's enough about me and my employer. So I'm going to start off by talking about the LeftPad problem. Very quickly, because this is really an on-the-line 25-minute talk, and I'm not entirely certain how much time I have left now. So in March 2016, a developer removed a library called LeftPad from NPM. NPM is the Node.js equivalent of PyPI, a big database of packages for that ecosystem. And when this library was removed, it broke lots and lots of libraries that depended on it. It turned out LeftPad had been downloaded 2,486,696 times in the month before it was removed. It was one function. Consisted of 11 lines of code that padded a string to a certain length by adding characters to the start of the string, hence LeftPad. And lots of people at the time thought that this made the JavaScript community look kind of stupid. Why would anybody publish a library consisting of just 11 lines of code? Why would anybody use it? Now, the fact that it could be removed and cause this kind of chaos is a problem, but personally, I think it made the JavaScript community look awesome. And if you disagree, you can fight me on Twitter. So in my opinion, LeftPad was not a problem. LeftPad was a solution to a problem. Because the JavaScript standard library doesn't contain a solution for adding white space to the start of a string, the developer of LeftPad solved the problem himself and published the solution so other people could take advantage of it. Because it's really easy to share code with NPM, people do, with really small libraries. The type of thing you'd normally find on Stack Overflow or in a gist. But copy and paste is not how you should be sharing code. There's no way to issue updates, bug fixes, security fixes, if that's the way that you're sharing code. And I feel in the Python community, which I belong to, that people are slightly afraid of setup.py. There's a whole bunch of different tools that work with packaging in Python. They can be complex, and the docs and best practice can be a bit tricky to put together. But they're getting better all the time, and hopefully this talk will help with that. So every time you publish code, you make the Python ecosystem stronger. You make somebody else's life easier. Where would we be if Django, NumPy, or Pandas had never been published? The Python ecosystem is not just the Python language. It's made up of all the libraries that we use, and actually all the resources we use to learn different techniques with Python. So, moving ahead, let's actually make a package. So this talk is really, it makes the assumption that you've written some code in your own project that you're kind of proud of. So we've all written Hello World over and over again. Wouldn't it be so much easier if we didn't have to write it ourselves and we could just pip install it? So we've extracted our code into a file called helloworld.py, it just makes sense. And we put it into a source directory. I'll explain why in a moment. I'm being gestured to hold this closer to my mouth. And then, so inside the source directory, we've now got our Hello World Python file, and the source directory is in a folder itself called Hello World. And in that directory, and our project directory, we put a new file called setup.py. And let's have a look inside. So The first thing to note is that we're importing setup tools. This never used to be best practice because setup tools is a third-party dependency. We used to use distutils, which is distributed as part of Python. But pip includes setup tools, so you already have it. It's more powerful in many ways than distutils, so we're going to use it. That's the current best practice. And the rest is really just config. It looks like a function call, but it's actually just configuration. So in here we've got name, and further down we've got Py modules. Those will usually be the same thing, but it does depend. The name is the thing that you pip install. And then the thing that goes in Py modules is a list of the things that you can import into your code. Your version for your first release will usually be something like 001, implying that it's unstable. As part of the packaging process, you're probably going to be redeploying again and again and again until everything is kind of right. And then you can start incrementing your minor and major versions to show that you have a certain level of stability. And we need the last line, which is just kind of a magic incantation, simply because we've put our code in a source directory. So let's test it. We've barely done anything, but we actually already have something we could publish in theory. So in our terminal, if we run the setup Python file with this bdist wheel command, it will generate us a binary wheel distribution. So a wheel file is the standard for pip these days. And it prints out lots of output, most of which I've removed. But the main line is the one I've highlighted, which shows that it's copied our source file into the lib directory, which seems kind of important. So looking at everything that is contained in our project now, we've got a lot more stuff. We had 2 files and a folder before, and now we've got this egg info folder, which I'm going to ignore for the rest of the talk. We have a build directory with various sort of things that were created as part of the build process. And then we have a distribution directory, dist, which contains our wheel file, which was created. So it's basically a zip file with some files in it. So we know it builds, but we don't know if everything we need is in that file. So let's check it out. So we can test whether it works or not by pip installing it. So if you've used pip install before, you may not have seen this. This magic -e dot incantation at the end of pip install. So what this says, the -e flag says we're installing a Python package as an editable dependency. So what that means is it's not going to copy our Python code into our virtual env, it's just going to link it into our virtual env. So the code that's actually being imported is the stuff that's kind of described in our setup file. And the dot is our current directory. So it's basically saying install the current directory as an editable dependency, which means that when we import our module, it's importing the code. When we install it, it's installing the setup file in our current directory. And then so that should make, even though our code is under a source directory, it should now be importable. So now if we run the Python REPL, we can import our function from hello world, and then we can call it, and everything works okay. So this is going to get a bit tiresome if we have to do this every time we modify our package, so we'll cover that in a minute. But in theory, we can upload this to PyPI now. We know it works, but I feel there are about 3 things we need to do first. So those are documentation, testing, and there's a bunch of housekeeping we should do first. So we're going to need a gitignore file. I really recommend this site, gitignore.io. It contains a bunch of different gitignore templates from that I think GitHub produced originally. If you type Python in that search box and hit create, it will basically give you a big text file in the browser. You can copy and paste into a .gitignore file in your current directory. So, and then we need to choose an open source license, because if we don't have a license file, we're technically not distributing our code. Nobody is legally allowed to use that. I really recommend this site, chooselicense.com, which can make deciding between the different libraries much simpler. And again, it will eventually give you the sort of dump of the text that you need to copy into a license.txt file. And then finally, we're going to add some metadata to our setup file. So there's a URL at the bottom here from PyPI which lists all the possible classifiers, and it's an enormous list. And here we've just chosen to point out that this module works in Python 3 specifically because it has an F string in the code. I don't know if you noticed that. It's only compatible with 3.6 and 3.7 currently. It will hopefully be compatible with 3.8 when that's released. We should test that first before adding that to this list. We've added a line that describes the license file that we've decided to use. So in this case, I just chose GNU GPL, kind of at random. And it says that it's OS independent, so it should work on more or less any platform. So then before we write documentation, we need to choose a format. We basically have two choices in the Python community. We've got restructured text, which is Python specific. It's known within our community, but not usually outside of the Python community. It's very powerful. And we can use Sphinx to generate a static documentation site if we want to upload to, say, Read the Docs or our own hosting. If we choose Markdown, it's more widespread, so if we're working with a library that has more than just Python code in it, that may be a better choice. It's also simpler, and there's an equivalent to Sphinx called MakeDocs, which will generate our static site of documentation, and it's also compatible with Read the Docs. So I've chosen Markdown for no good reason, really. But once we've chosen a format, we can write our README. So a README should contain a title and a short description of what the module does. It should contain an installation section that tells people how to install it. It should create we should have a usage section that just kind of shows some sample usage of the library, like how we might use it. And once we've written that, that's kind of a long description of our module. So we should actually import that into our setup metadata. And because the setup.py file is code, we can add this line to just open the README file, read in the contents into a variable, and then we can add a couple of lines to our setup config. So we've added the long description, which is the contents of our README, and then this thing that's relatively new in PyPI, because Markdown support is relatively new in PyPI, we can add long description content type and give it the MIME type to say that it's Markdown. And so when we push this package to PyPI, it will now format our README as the main documentation page on PyPI, which is kind of helpful for people. So I said we needed to do some testing. I recommend PyTest on pretty much any project. PyTest is awesome in so many ways. But it is a third-party dependency. It means that any contributor to our project is also going to need PyTest installed. And we currently have no way to describe dependencies for other developers. So we need either a requirements.txt file or a pip file. And Pipfile and pipenv are kind of the new hotness, so I'm going to cover those. So let's write the pip file. Fortunately, we don't need to write a pip file because pipenv will actually manage the contents of this file itself in most ways. So we can both create the pipenv file and start filling it with useful content by running this first line, pipenv install -e dot. You'll notice that looks very similar to the pip line I described earlier. Excuse me. And then we can also tell it that there's a development dependency, which is PyTest, which should be greater than or equal to version 3.7. And then because pipenv manages our virtual env as well as our dependencies, we can run pipenv shell, which is the same as activating our virtual env. So in that case, once we've dropped into our virtual environment, we will have both PyTest and our library's code available to us in the Python path. So this is the pip file it creates. There's some other stuff in there as well, but this is the important stuff. So that first line, or rather second line under the packages header, is basically says we have an editable dependency, which is our current package. And then under dev packages, we've got our PyTest line that says, as we specified, it should be greater than or equal to version 3.7. The thing that makes Pipfile a better solution than requirements.txt is because when it went away and installed the dependency we specified, it also created this lock file, which is a big JSON file. And that contains, so you'll see the line I've highlighted in red, says version equals exactly 3.7.2, which is the version it got when it asked PyPI for a version that was compatible with 3.7. That's the current latest version of PyTest. And so you should commit this file as well as the pip file into Git. And then other developers, when they run pipenv, will get exactly what's specified in this lock file. And then you can run pipenv, I think it's upgrade, it's either upgrade or update, and it can go away and get new compatible dependencies and update the lock file, but you should only then commit that after you've run your tests and they've passed. So this means the advice for how you specify your dependencies is slightly different to what you may have read about requirements.txt. So your setup file is for production dependencies. So we don't have any dependencies right now, but if we did, it would be something like Flask, Click, NumPy, basically dependencies for running your code. And the version should be as relaxed as possible. So you should test under multiple versions of each of your dependencies and keep that span as wide as you can. So only essentially create rules for versions that can't be used because they literally don't work. The pip file is for development requirements, so it's for things like PyTest, mark, coverage, PY, and the versions. This is where it differs. The version should also be as relaxed as possible because they're locked in the pip file. Whereas before with requirements.txt, you should use very specific versions because you want other developers to be working with the same versions of tools that you're working with, because that's going to make their lives easier. So now we have PyTest installed. We can write some PyTest tests, so I'm just going to kind of skim over. And we can run our tests by running PyTest, and you'll see the green line at the bottom, our tests passed, which is both surprising and pleasant. And now just to pause briefly to show you what our project looks like now. So we have our license file, we've got a couple of pip files, we've got our README, we've got our setup file, we've got a source directory with our code in it, and then we've got our test code. The test code could be under a test directory. If we had more than one, we would probably want them under a test directory. But the simpler solution, if you just have one file of tests, is to stick it in the project directory. Something that often gets either skipped 5 minutes. Okay. So you should also create a source distribution. You do this by running sdist. You'll notice when I ran this the first time, it complains that there's some stuff missing from the setup file. So we're missing a URL and some author data. So if we go back to our setup file, we can add those in. That's simple enough. But then it creates this gzip tarball, which you can list. Because it's just a normal tarball, you can run tzf on it to list all the contents, and you'll see it's missing some stuff. And the reason is we haven't created a manifest input file, a manifest.in file. And so it's made some pretty good decisions, but there's just certain files it doesn't understand, so it's skipped them. Whereas really the content of your source distribution should be the same as what you have in Git, which is great because there's a tool that will write you a manifest file based on what you've committed to Git. So normally you can use this to validate your manifest.in file, but if you run it with the create flag, it will create you one. It's not all, well, it usually works. It can be a little bit broad in terms of the patterns that it adds to the file, so you may want to edit it by hand before you add it to your Git file. But it's a nice way to get up and running, certainly. So now if we build another source distribution and then list the contents, you'll see it now has our pip files, our README, and our test file in. So now we should publish it. We're definitely at the point where we can publish now. So we build it, both the binary distribution and the source distribution. You can see it creates them in the dist directory. And then we use Twine to upload. So there's a few reasons to install it, to upload to PyPI using this third-party tool. Really what it does is you pass it a path that you want to upload the contents to PyPI. It will ask you for your PyPI username and password, and then it will upload the files securely to PyPI. And then if you go to PyPI quickly, there's a home page which has a box on it listing the most recently updated packages. Hopefully yours is still in that list. And then if you click on the link, it will take you to the PyPI page. You'll see that because I said it was Markdown, and it is Markdown, it's formatted it nicely on the page. Cropped off the bottom is a link to our GitHub repo. So that's all pretty good. So we're missing a few things. This is really the bare essentials. I'm going to skip over the tox description because it's kind of 5 minutes short. Once you've got tox up and running so you can test under different versions of Python, you should then write Travis config so that you can test under continuous integration. So every time you push your changes to GitHub, for example, it will then create virtual machines and run your tests in a completely clean environment. So then you know your code is more likely to run on somebody else's machine when they pip install your code. So for extra credit, you can add status badges to your README. You can manage versioning with bump version, which is a neat little tool. You can test on different platforms. You can write more documentation. This seems like a lot of work, doesn't it? This took me about 2 days to get all of this up and running the first time for this talk. So I recommend not doing any of this. I really had to get to the end of this talk, otherwise it makes no sense. So this is boring, time-consuming, and error-prone. And the thing that's really good for tackling boring, time-consuming, and error-prone tasks are computers. There's a tool called Cookie Cutter, which will generate you a project based on a template. It has a bunch of different templates for different things, both within and outside the Python community. So let's pretend we didn't just spend all that time doing that by hand. Instead, we used Cookie Cutter. So you pip install Cookie Cutter, you run Cookie Cutter. I pointed it at this great library template by Yonel. So it will download that from GitHub and then run it locally. It will ask you lots of questions because it's less opinionated than I am, and it offers you choices for your testing framework and various other things. I have 1 minute left. So it will ask you lots of questions. You copy in your code and your tests, which we've already seen. You will probably need to make some minor manual file tweaks, but hopefully you know how to do that now. And then you're done. It took me 5 minutes to do that when I was just testing it for this talk. So I could have cut this whole talk down to the last 2 slides if I'd wanted, instead of wasting all your time. But hopefully this gives you a good overview of good packaging practice and encourages you to publish your own packages on PyPI. The full slides are up on GitHub at this actually slightly unreadable bit.ly URL. That's 4 Ps. So it's like publish perfect Python packages on PyPI. And feel free to follow me on Twitter. I am around the conference for the whole time, so come and talk to me if you have any questions. Thank you very much.
Sorry, last time at the beginning.
It's not your fault.
I'd love to listen.
The last